Here I am Vadel Sagar. Welcome to the part number 18. As I said you in the part number 17, today we will discuss exercise part of the chapter number 1. So let's go without wasting time. So you may compromise in a little bit in a clarity, but you can see these videos in your laptop or bigger screen. You will get the better result. Okay, let's start. 1.1. What is the force between two small charge sphere? You have a two charge sphere having the charges which is 2 into 10 to the power minus 7 coulomb and 3 into 10 to the power minus 7 coulomb placed at the 30 centimeter apart. So that picture you may have clear. The two sphere both have an independent charge on it, and then they are the far apart from the 2 foot. 1 foot 30 centimeter. Okay, so that your q1 q2 and this is r, which is 30, going to be 0.3 meter. And if you want to finding the force, then the force is equal to fundamental equations of the Coulomb's law, q1 q2 upon 4 pi epsilon 0 r square, otherwise k q1 q2 upon r square. Just we are putting the values of it, as we know the 1 upon 4 pi epsilon 0 is the directly 10 to the power 9 into 10 to the power 9 Newton meter square coulomb minus 2. Please take care while deriving this unit of it. Just we are putting the respective numbers there in the respective sides. You will get the answer is 6 into 10 to the power minus 3. So don't judge this answer is completely right. Do in your calculator. If you are getting this right answer, then you can proceed for your yours. Okay, this is the completions of the first example. I'm going to the second example. The electrostatic force on the small sphere. So one small sphere whose electrostatic force it is feeling, but that sphere has charge is 0.4 microcoulomb due to the another sphere. So the two sphere, again two sphere you have, but here we have one positively charged, as you can see, and one is negatively charged. Then they are feeling the attracting force. How I judge attracting? Because both are the opposite charge and they feel force 0.2 Newton only. A task what we have to find, what is the distance between two. Okay, at low force લાગે છે તો બંને કેટલા અંતર દૂર હશે. And that B part I'm saying in Gujarati, that is me for the laugh point of view. What is the force on the second sphere due to the first? Actually that I can answer the second one quickly. B task, they are already answered in the question. 0.2 Newton force, both are attracting force. So the one sphere whose applying or the filling force by the second sphere is always equal to the second sphere to the first sphere. Because if you are finding the q1 q2 upon r square only, so the q1 is still number same, q2 is same number, and r is the distance between it the same number, then okay, force is also given. Then it is not like that one sphere is filled this much force and the another sphere filled the this much force. No, it is same both for the both system, the force is same. So the answer of the second is the 0.2 Newton, it is given. Now what the distance it should be, so the r we have to find. So this is what the given data, 0.2 Newton, 0.4 microfarad, so 0.4 into 10 to the power minus 6 minus 0.8 to the a minus 0.8 to the 8 to the 10 to the power minus 6. This is what the fundamental Coulomb's law what we are using. This is our k value constant. Then your r square denominator goes up, so the respective sides of q1 q2 upon 4 pi epsilon 0 and f you bring it downside of the equations. Now put the respective values in this respective places. 4 pi epsilon 0 is a whole number is 9 into 10 to the power 9, 4.4 10 to the power minus 6, 8 10 to the power minus 6. Here we are finding the distance. So no matter of this minus sign indication, minus and plus is the charge. Okay, and they are the showing the which type of attraction or repulsion it has, which type of force it has. And then at the end r square you are getting some 0.12 meter because of the 10 to the power minus 4 is the, and then it's under root of 12 10 to the power minus 2 centimeter, because somewhere you may have, no, it is a 12 10 to the power minus 2, then it will be 12 replace your 10 to the power minus 2 to 0.12 only. Is it okay? Here you get 144 10 to the power minus 4 if you are doing in your calculator. then this is a r is equal to under root of its 144 under root is a 12. So the answer is 112 10 to the power minus 2. How minus 2? Because minus 4 under root is also 10 to the power minus 2. Then the answer is 12 10 to the power minus 2. That will be reduces to the 0.12 by shifting a point. Okay, the distance between two sphere whose charges is 0.4 and minus 0.8, it will be 0.12 meter. It means 12 centimeter, I can say. That B is already I answered. Still you can read by pausing this video. 1.3. Check that the ratio K E square upon G M E M P is dimensionless. That they are asking to check there whether this ratio is going to be dimensionless. And why they are asking? Because their K and G is constants. E is nothing but the two charge is square, and Me and Mp is the mass of the electron and proton. So whether these are having dimension or that not, looks up to the table where their constants are having in the values, and what does the ratio significance? It means value hodwani છે, and one has to be conclude something at the end. Okay, so let us start. Before the starting, I want to explain you, this is nothing but the ratio of the electric force and magnetic force, or electric force and gravitational force, sorry. So electric force is the Gauss law. F is equal to K E square upon R square, K E square upon R square, and whole denominator is the G M E MP upon R square. But R square cancel out, so the only the K E square upon G M E M R square. So ultimately both are forces. Numerator is the electric force, and then denominator is a gravitational force. Ultimate the force ratio is always dimensionless. Before proceeding in the detailed study of the calculations with the steps, as a common sense scenario, you can answer it is dimensionless. It should be dimensionless. And by the 11th standard, the first chapter of the knowledge, I can answer it. The electric force is a very strong than the magnetic gravitational force. That we will prove by number how much strong it has. So let us start. They are explaining this, what the units of the respectives, what the quantities are present here. K is the nothing but the 1 upon 4 pi epsilon 0. 4 pi is constant, so the epsilon 0 unit is the K unit, is the inverse of its. E square is the Coulomb square, and gravitational unit constant, and MEMP is the masses kg, and then they are reduces, they are getting the M0, L0 and T0 because there is a dimensionless. And now onwards we are just know the numbers of the K is equal to 9 into 10 to the power 9, E is the charge 1.6 into 10 to the power minus 19 square upon G is the 6.67 into 10 to the power minus how much? Minus 11. Mass of the electron is the 9.1 into 10 to the power minus 31. Mass of the proton 1.66 into 10 to the power minus 27. Put the respective numbers, you will get the one number which is 2.3 into 10 to the power 39 something. So that much time stronger electric force than the gravitational force. This is the justification or the conclusion of this 1.3. Explain the meaning of the statement electric charge and the body is quantized. Electric charge body is always quantized. No meaning. What the meaning it should be? Electric charge is the body is always quantized, and this is a mean that is it always the integral multiplication 1 2 3 4 or n number of electron can be transferred from the one body to the another body. The charge is not transferred in a fraction. It cannot be okay. One sphere who has the charge and another sphere is the zero charge. By doing somehow, by the applying the electric forces on the charges, by the joining a battery, somehow this gap is not much, or you are just connecting each other, the charges start to transfer. As you know, if the first sphere is a 10 charge and another sphere is a 0 charge, if you are just connecting it, it will be the phi charge. It's going to be equalized. It is called the nullification, equally electrostatic equilibrium condition. And during this transformations of the charge from the one sphere to the another sphere, not always the sphere, but the sphere scenario is always in this our brain. It's a much easier concept for us. That's why we are taking. Okay, now while it's transferring this charge, it never happened the one or though it means 1.5, and it can never be possible. It is either it is one charge, either two charge, three charge, five charge, it never be for 5.4. So there is a no such kind of fractional, no fractional thing can be possible. Hence a body possesses total charge is always integral multiplications of the E, either 1, either 2, 3, 4, 5, or likewise. In a macro, okay, second task, why can one ignore the quantizations of the electric charge when they're dealing with the macroscopic? Okay, now this is the already explained I during the our discussions regarding the chapters somewhere. Macroscopic it means you are outside, and you are seeing the whole surface as a charge, so you are not bothering with the how much charge. It means macroscopically it means 1,000 rupees and you are just adding 1 rupees, so that will be not affecting much, so it is called macroscopic view. But if you are go inside and the individual one rupees hisab you are doing, then 1 rupees is, even though it is makes matter. So you are seeing the microscopically, because you are calculating while some examples or anything in such a cases you are precise up to some point. It means 110 rupees point 69 paisa, then 1 rupees cannot ignorable. So this is called microscopic calculations, and then you are just having rough number to saying something, this much rupees I have. If you have 1001 rupees, then you no matter to take say that the 1001 rupees, you just say that 1000 rupees I have. This is called macroscopic view. This is the, while you are seeing a macroscopic, then why you are ignoring the quantization? We can ignore because it's not mattering. The macroscopic large scale, the charge is like looks like a continuous huge compared to the magnetic charge. Hence the quantizations of the electric charge is no use of the macroscopic scale, therefore it is ignorable, and the charge is looks like a continuous system. 1.5, when a glass rod is rubbed with the silicon, this I explained you in detail. You can go in a front initial stage of this our chapter, and you can pause it, read it also. I no need to I explain. Okay, this is 1.6. 4 points are there, q1, qb, qc and qd. Respective numbers are you can able to see are located at the corners of the abcd of the square. That the side are the square side is the 10 centimeter. What the force is feel by the 1 microcoulomb which split at the center. Okay, center is made up of the 1 microcoulomb, and what the force feel by the center charge. Okay, the center charge is positive. This two is the positive 2 and these two are negative. So this two positive and this center is also positive. So okay, suppose the system of OA, start with the OA, this is positive, this is positive. So something number, or the if you are start with the FA force calculation or the FOA, it means force on O due to A. This is a what the basic way of doing the calculation. Then you start like K QA QO upon R square. You may have to find this is distance also, but no need. Why? Suppose any number comes at the end while you are doing calculation, this will be not same as what, because it here also 2 and here also what the charge you are already taken in this example also, and also this distance is same. So why you are wasting your time to calculating this force and this force and this force, this force and this force, all three are the positive. These two systems are repelling each other, so this charge is going to be this side because these are repelling, but this force is also positive and this is also positive, so both are also repelling each other and equal in a magnitude. If the suppose you are just open your hands and one fellow who stretch from the left side and one fellow who stretch from the right side, both are equal in magnitude, so you are staying in your position. Instead of, if there is maybe the force of stretching force may be not same, then you are move towards the higher side, higher force field side. here, but the magnitudes are same, so the staying on the A point, so there is no force field. Okay, and the same task, this two side is the minus 5 microcoulomb and the center is a 1 microcoulomb. The center is positive and the sides are negative, so both are attracting in nature. So the again there is force is same, both are attracting, so still your O will be the O. And this what I said is completely written here, you can read. So the force field by the center charge, it will be 0. 1.7. And electrostatic field lines is continuous curve, that is the field line cannot have sudden break. Why there is no sudden break, why not? Okay, and then B is explain why two field lines are never cross each other. Okay, the A, an electrostatic field lines is continuous curve because a charge experience a continuous force. If you are putting your charge near to the charge system, the charge which you are put on is always feel continuous force. That's why the lines are can be, because electric field lines or magnetic field lines is a virtual concept, actually it is not there. But if you are okay, it is a virtual concept, then how you can judge it is continuous line? Because we can judge via this concept, we can judge because the force field by the whatever you are putting with this near to it is continuously, there is no break. That's why I can say the continuous line is okay, sorry, the electric field lines is continuous. The field lines cannot have sudden break because the charge move continuously and does not jump from the one point to the another point, because the feeling force is continuous, then the charge line should be there. Okay, if two field lines cross each other, suppose it is never crossed, but suppose it's crossed, then the electric field intensity will not be two directional at this point. If it is crossed, then this that point, as I said you, electric field lines, if you know, if you have a knowledge of electric field lines, now electric field line curve suppose like that, and you want to find this point, don't see the background what I have, I'm just with the yellow lines I'm trying to explain you what we seen. Suppose this is a electric field lines, okay, suppose like this electric field lines. Okay, on this point we have to find the directions of electric field lines. This is the directions of the what is called tangent to this curve. This is a particular, suppose these two field lines are cross each other, then this is the confusing direction. There is no such kind of specific direction we can indication, so this is a confusion, and this is not happen every, there is no such kind of confusion ever we seen. So they are never crossed, we can justify this is not possible, hence two lines never cross each other. Okay, thank you very much.